When creating simulations or models, we often need to incorporate algebraic operations. Take, for example, modeling the temperature control of a house. As part of this larger simulation, one step is to convert the thermostat temperature from degrees Fahrenheit to degrees Celsius for the other system components. We need to implement this equation within the simulation. How do we perform these algebraic operations? To do this, we'll start by writing out the math operations needed as our initial Fahrenheit signal moves through the model. This will help us identify the required Simulink blocks and how to connect them. We start by taking a signal in degrees Fahrenheit, subtracting 32, and then multiplying that difference by 5/9 to arrive at degrees Celsius. Now, let's mirror this flow in our model. To find blocks representing arithmetic operations, we look in the Math Operations library in the Simulink library browser. So, to subtract 32 from our Fahrenheit signal value, let's use the subtract block. The value being subtracted remains constant throughout the simulation, so we use a constant block from the sources library and change the constant value to 32. We'll use a constant block to represent the target temperature in degrees Fahrenheit as well. To finish this step, let's connect the constant block representing the input temperature to the plus port, and the constant block for 32 to the minus port. The resulting signal now needs to be multiplied by 5/9. We do this with the gain block from the Math Operations library and change the gain parameter to 5/9. Connecting the output of the subtract block to the gain block finishes the conversion from degrees Fahrenheit to degrees Celsius. Now that we've modeled our conversion, how can we be sure we've implemented the math correctly? Let's test the model with a couple of values to ensure it's working as expected. To view the result, we use the display block from the Sinks library. Water boils at 100 degrees Celsius, which is 212 degrees Fahrenheit. So let's see if we get the correct result. Click Run and… Great! The display block shows an output of 100 degrees Celsius. And water freezes at 32 degrees Fahrenheit, which is 0 degrees Celsius. So it looks like our conversion works and is ready to be integrated into our model for a home temperature controller. Ah, just right.